Let's do a couple of problems involving cylindrical coordinates. So let's do one of them. So let's say we have a cylinder. Domain K is defined as this: x squared plus y squared is equal to 4. It will be a solid cylinder with radius 2, centered around the x of symmetry is the z-axis, and z is from 0 to 3. So this being said, let's try to find the triple integral over k of x plus 2z dv. Okay, so this is one of the problems which you should, if possible, try to exploit the symmetries of the integral. So for this problem, this cylinder can look like this. Z-axis, x-axis, y-axis, z-axis. Radial cylinder is 2, and the height of the cylinder is 3. So in cylindrical coordinates, we can say r is from 0 to 1, 0 to 2, theta is from 0 to pi because of the rotational symmetry, rotationally symmetric solids theta from 0 to pi. Then z is from 0 to 3. So in cylindrical coordinates, this solid cylinder is a box. It's a very one of the big advantages of integrate using cylindrical coordinates on integrate over solid examples or part of cylinders. It's a box in cylindrical coordinates. So how to do this integral? To exploit the symmetries of the problem, because the function x is symmetric, anti-symmetric about the yz plane, and the cylinder is symmetric about the z-axis. Due to symmetry, the triple integral over the cylinder of the solid cylinder of x dv is 0. So we can say this integral equals to triple over k of x dv, which will be 0 by symmetry, plus triple over k of 2z dv. So we only need to calculate the triple integral over k of 2z dv. But using cylindrical coordinates is triple integral over k 2z as r dr d theta dz. Right? Because r dr d theta dz is the volume element in cylindrical coordinates. Okay, so let's try to continue. Equals what is now? Because the domain of integration is a box in cylindrical coordinates, we use separable over rectangles paradigm SOR. So we get the R integral is integral from 0 to 2 R dr. Okay. The theta integral from 0 to pi of d theta. The z integral from 0 to 3 2z dz. Okay, so this will be r squared over 2 from 0 to 2, that's 2. That's 2 pi. The z squared from 0 to 3, that will be a 9. 9 times 4 pi is 36 pi is the answer to the problem. And very, very good shortcut was using the symmetries, which is the triple integral of such a solid of x dv is 0. For the same purpose, triple integral of the same solid of y dv is 0. Okay, so the only coordinate out of x, y, z will give a non-zero integral over such a solid is z. Okay, that's problem number 1. Let's do another one. Over a slightly less, more complicated solid is what is calling. So K will be the solid described by x squared plus y squared greater or equal to 1, and Z is between a lower surface and upper surface. Let it be a simple respect to Z axis. Z is between x squared plus y squared and 1. So everything evolves within a solid cylinder centered around the z-axis with radius 1, and between a lower surface, which is a paraboloid, and the upper surface, which is a plane. So what will be the picture here? Lower surface is z equals to x squared plus y squared. It's a paraboloid. Lower surface, z equals to x squared plus y squared. Upper surface is a plane. Upper z equals to 1. Lower z equals to x squared plus y squared. Everything evolves between a lower and upper. Okay, so now if you look in perspective, project this solid onto the xy plane, what would be the projection? It would be the disk centered at the origin with radius 1 in the xy plane. So this solid evolved in a lower surface is equals to x squared plus y squared, and upper surface is equals to 1, and everything is above the base domain x squared plus y squared less than or equal to 1 in the xy plane. So this would be the z-axis, x-axis, y-axis, and then in the xy plane we have the disk center of the origin of radius 1. X squared plus y squared less than or equal to 1, and of course z equals to 0 for this disk. Okay, so let's find the triple integral. Let's see what was the promise. Triple integral over k of x squared plus y squared squared dv. Okay, so let's see. So let's try to re-express this k in cylindrical coordinates. So what we get here? Because of the rotation symmetry, nice like a circular symmetry around the z-axis, theta is between 0 and 2 pi. What's the meaning of small r in cylindrical coordinates? R is the distance of the z-axis, right? So r is between 0 and the maximum elongation from the z-axis possible is 1. So r is from 0 to 1. Theta is from 0 to 2 pi. We got r, we got theta. Now z. Z is between the lower and upper surface, like we see here. So z is between the lower, so L of xy is x squared plus y squared, the lower surface, and the upper surface, which is 1. So this will be k expressed in cylindrical coordinates. Okay, so which is the same thing as a domain. Only now the coordinates are theta and z, but otherwise everything evolves above a plane domain D, above a lower surface L of x and y, and upper surface U of x and y. Okay, so what will be a triple integral over k of x squared plus y squared squared dv? So this will be triple over k. X squared plus y squared is r squared. R squared squared is r to the power 4. dv is r dr d theta dz. So this will be triple over k. Okay, so let's see. I need r to the power 4, r to the power 5, dr d theta dz. Okay, so let's try to iterate the integrals in this case. integral, integral, integral. Let's leave for last the integral from 0 to 1, r the power 5 dr. Then integral from 0 to pi d theta. Then on the inside, the only integral with the variable limits, integral from r squared to 1, because the lower surface is r squared, upper surface is 1, so from r squared to 1 was left. Integrated the dr, so we got rid of this, we got rid of this, then dz here. Okay, so the last integral is from r squared to 1 of dz, so obviously this will be 1 minus r squared. And then, if we integrate the constant for the purpose of integrating theta, it will be 2 pi times 1 minus r squared. So let me take 2 pi in front of the whole integral being the constant. Integral from 0 to 1. What's left? Is left 1 minus r squared with r to the power 5 is r to the power 5 minus r to the power 7 dr. That will be 2 pi times 1 over 6 minus 1 over 8. 1 over 6 minus 1 over 8. 2 over 48 is 1 over 24. Is 2 over, so 2 pi times 1 over 24, which is 2 over 48. 1 over 6 minus 1 over 8. Now, 2 over 24 is cancelled, we get 12. The final result is pi over 12. Okay. And the last one from the list, exercise 3. Involves a trig function of the integrand. This one. Again, the same standard cylinder. K is x squared plus y squared less than or equal to 1 and z between 0 and 1. So solid cylinders with axis of symmetry z axis, radius 1 and height 1, right? So let's find the triple integral over k of sinus of pi times x squared plus y squared dv. Okay, so let's see what we get here. In cylindrical coordinates, is triple integral over k sinus of pi r squared, because x squared plus y squared is r squared, r dr equal to z. So again, the cylindrical coordinates, r is between 0 and 1, theta because of rotational symmetry from 0 to pi, and z is from 0 to 1. So because in cylindrical coordinate is a box, we use separable of rectangles. And the r integral from 0 to 1 minus of pi r squared times r dr. Theta integral from 0 to pi d theta. And lastly, the z integral from 0 to 1 dz. Now this will be 1, this will be 2 pi. And the only thing which needs to some attention is this one. So integral from 0 to 1 sinus of pi r squared times r dr. Let's do a substitution. Pi r squared equals to u. Equality of differentials, 2 pi r dr equals to du. R is from 0 to 1, u is from 0 to pi. So u is from r equals to 0, u equals to 0, and r equals to 1, u equals to pi. 0 to pi. So after changing the variable, this becomes integral from 0 to pi sinus of u. RD, what's RDR? RDR from here is 1 over 2 pi times u. So 1 over 2 pi, take it in front of the integral. 1 over 2 pi du. 1 over 2 pi is here du. And let's antiderivative is 1 over 2 pi. Antiderivative will be minus cos u from 0 to pi. Minus cos u of pi is, so minus cos pi is minus 1. 1 minus cos 0. So 1 plus 1 is 2. So this will be a 2. So this will be 1 over pi. So the final result, 1 over pi times 2 pi times 1, that's a 2. And these are nice, the set of problems about 3 parameters in cylindrical coordinates. They're basic introductory problems.